Hi, my name's Eric Felkel from Zygo Corporation, and we're at Photonics West 2017, and we're going to talk a little bit about doing surface metrology in adverse environments. So what we have here is our Z-Gauge Plus coherent scanning interferometer. It's a scanning white light system for measuring surface topography, texture, all completely non-contact. And one of the challenges of doing precision surface metrology is doing it in an area where you could have lots of vibration or turbulence. Wanting to bring metrology closer to the manufacturing floor, closer to the point of operation, is a common goal among precision surface manufacturers. And with the Z-Gauge and the Z-Gauge Plus profilers, we've introduced a technology we call SureScan. SureScan is basically a way that we can eliminate a lot of the vibration effects that can compromise the metrology performance for these systems. So measuring in less than ideal environments is definitely a challenge to metrology. And a trade show floor is a great example of a lousy environment. It's noisy, things are vibrating, and to do precision metrology in an environment like this is definitely something that most people wouldn't expect to be able to do. With this instrument, basically all I need to do is tell it to measure, and what we're going to see is metrology of a sub-nanometer diamond-turned optical surface measured, with people walking around, with the floor shaking. So I think what we've been able to show is that even in a lousy environment like a well-attended trade show convention floor, with a tool like the Z-Gauge and technology like SureScan, it's totally possible to do very precise surface metrology. Take this environment and extend it to your manufacturing environment, and really tools like this are a way to bring metrology closer to manufacturing floor and really shorten manufacturing cycles and improve manufacturing processes across the board.
Hi, I'm Erin McDonnell, Associate Product Line Manager for Laser Interferometers, and we're here at Photonics West 2017, and we're going to talk a little bit about doing metrology and making good measurements in non-ideal environments. First tool we're going to look at here is our Verifier HD system. Important things you want to keep in mind when making a measurement in a non-ideal environment is that you need to have some way to kind of freeze the vibration out, or to make a measurement quickly enough that you're not going to see that much vibration. One thing that we were able to do with the HD here is a Zygo developed algorithm called QPSI. It's a more vibration robust algorithm that allows us to do a slightly different connection that allows us to eliminate some vibration source. Additionally, this tool's got a camera that runs at 210 Hertz, allowing us to take the measurement much faster so that there's less vibration that you need to get rid of in general. That allows us to be able to make measurements even directly on axis in a bad environment like a trade show floor. So certainly a trade show floor like this one is definitely an example of a non-ideal environment. Typically you would never want to do metrology measurements with an interferometer, especially without a vibration isolation table. But with our QPSI algorithm, we're able to make measurements even on a trade show floor like this. So I just hit measure just like you would with a traditional phase shifting interferometry, but unlike PSI, our QPSI algorithm will allow for data to be taken quickly and easily and without any fringe print through. So now we're going to take a look at a different tool. While QPSI is great and it's useful in many environments, sometimes QPSI just isn't enough for those really, really bad environments. Say when you're trying to measure an optic that's across the room on a separate table. So in that case, we're going to use our Dynafit instrument. In addition to QPSI and PSI, like we saw in the Verifier HD, the Dynafit also has a measurement mode that we call Dynaphase. Instead of phase shifting, Dynaphase uses a carrier fringe technology where you intentionally induce a lot of tilt and then are able to take an entire measurement in a single frame. That allows us to really freeze the vibration and get data even in very adverse environments. As you can see here, we're making live measurements of an optical system without any issues and without any optical table.